Lesson 12, practice problems. In the first section, it asks to identify each property that is illustrated. Now let's go back and review those properties that we learned in our lesson. We have two identity properties, two commutative properties, and two associative properties of addition and multiplication each. The identity property of addition says that any number that's added to 0 is going to be that self, that number. So 5 plus 0 is 5. The identity property of multiplication says any number that's multiplied by 1 is going to be itself. 5 times 1 equals 5. The commutative property is talking about to commute means to change the position, to move something in the algebraic expression in which there's addition happening and when there's multiplication happening. When you're moving that position, here's how it works out in addition to multiplication. For every real number a and b, if you had a plus b, it's going to be equal to b plus a. Just because you change the order doesn't mean you're going to change the result. For example, 5 plus 2 equals 2 plus 5. Both equal 7. The commutative property of multiplication says the same thing. You can change the order. You can move those items around in the expression. As long as multiplication is still happening between those, you're still going to get the same answer. A times b is the same as b times a. 5 times 2 equals 10, so just like 2 times 5 equals 10. You've changed the order. Notice the 5 came first, then this 2. Here you've got the 2 coming first, and the 5 doesn't change the result. Still get the same answer. Commutative property again means you're changing the position or changing the order in which those numbers are in the expression. The associative property is talking about where those numbers associate or hang out with. And a lot of times this is going along with where parentheses show up in the expression. So for example, a plus b is in parentheses here, and then b plus c is in parentheses in the second part of that expression. Just because you've changed what numbers are being associated together when addition or multiplication is taking place doesn't mean you're going to change the actual result because the same operation is being carried out. So 1 plus 2 equals 3 in parentheses plus 3 equals 6 is the same as 2 plus 3 equals 5 plus 1 equals 6. Both get the same answer when they're changing the association or changing where those parentheses go. The associative property of multiplication just changes parentheses around the different types of factors in the expression because we're multiplying those numbers. A and b are multiplied together first, and then c. Here b and c are multiplied together, and then a. Because it's the same operation, all are being multiplied together, you're going to get the same result. For example, 1 times 2 is 2, times 3 is 6. 2 times 3 is 6, times 1 is 6. You get the same answer. Now let's go and identify those in our practice problems. Letter A says 5 plus 9 plus 8 equals 5 plus 9 plus 8. They read the exact same way. They're in the exact same order, but you have changed where those parentheses are. Therefore, you've changed the association. Here's our associative property of addition. Letter B, 0 plus 10 equals 10. You got an addition property, and you've got it being added to 0. Therefore, it's the identity property of addition. C, 15 times 3 equals 3 times 15. Here you've changed the order. You had 15 first, then 3. Now you've got 3 and 15. You'd still get the same answer of 45 between those two. That is the commutative property of multiplication. Letter D, 17 times 1. Anything multiplied by 1 is itself. That's our identity property of multiplication. In the next section, it asks us to tell whether each statement is true or false and to justify our answer using the properties, assuming that all of these variables represent real numbers. Letter E says a times b in parentheses times c equals a times b times c in parentheses. Notice you have associated or changed the parentheses. This would be the associative property of multiplication, but because they have all of the same factors being multiplied, you'd have the same answer. This is a true statement. Letter F, m minus z equals z minus m. Now you've changed the order, so you've got the commutative property, but because it's subtraction, the same answer is not like in addition. Addition, if you change the order, you still get the same answer. 2 plus 5 equals 7, and 5 plus 2 equals 7. Here, m minus z might result in one answer, and then z minus m might result in a completely different answer or even a negative number in comparison to what you got in the very first part of that subtraction. So these are not going to give you a true answer or an equal property here, so this would be false. Letter G, w plus 0 equals w. Anything added to 0 in the addition property is our identity property of addition. That is correct. That's true. Practice problems for lesson 12 so far have had us practicing identifying the different properties that we've learned. Now we're going to show how we can use those properties in a live situation. So as we're solving the problem algebraically, I'm going to use the property and justify each step to show you how you would actually apply that skill instead of just identifying which property that's being used in order to properly solve something. So let's take a look at letters H, I in our word problem, letter J. Letter H says 18 plus 7x plus 4. Here I've got two numbers that don't have any variables, and here I've got this variable digit that isn't going to allow that to be a like term. So I want to put these two numbers together. Which one of those properties could I use that's going to put like terms together with each other? I bet you it's the commutative property, because I've got to move these around so that they're actually next to each other, and then I can associate them together. So I would rewrite this: 7x plus 18 plus 4. You see, this is a positive value here. There's nothing written in front. We can assume it's positive. And now you have these two items that are written together, and you can use the associative property. So to move something from one place to another is to commute, and now these two are associated with each other. 18 plus 4 is 22. I cannot combine with 7x because that's not a like term with that variable being. So you again saw that this movement here was what we would call the commutative property, and this parentheses here would be the example of the associative property, where I'm associating those two things together and doing that portion of the algebraic expression first. In letter I, I've got 1/3 times d times 3. Now here you've got two factors that are being multiplied because they're right next to each other, and then the third factor is actually signified by this multiplication. Now, when I have a fraction and a whole number, if they're reciprocals of each other, I've got to remember the property in my head that's anytime that I'm multiplying a number by its reciprocal, its answer is going to be 1. So I'm going to have those things cancel out. I'm just going to have to rearrange the problem in order to do that correctly. So I would rewrite this again, and I would write it 3 times 1/3 times d. Now, because I've rearranged the order, again, that's my commutative property, to change where those things are located. Now that these are here, I can break this down and multiply 3 times 1/3. I would cancel both of those. They become 1. 1 times 1 is 1. 1 times 1 is 1, numerator and denominator. And my answer is going to be just simply d, because I now have associated those two things together and multiplied those items there. For letter J, let's read out of the workbook, or read out of our textbook what the word problem says. Erasers, markers, and paper can be purchased at the school store for the following prices, respectively: $1.45, $3.35, and $2.65. Find the total cost of supplies, justify each step. Now you're probably thinking to yourself, Mr. Shane, this is a simple addition problem. I could just write it like this and then add from the top to the bottom. You could, or you could start to learn some of our properties and apply these in a way that's actually going to make you better at math because of the way that you think about numbers. It's called number sense. When I see a number like this, 65, I'm automatically thinking, well, how close is that to actually being a full dollar in dollar amounts? It's actually 35 cents away. Now, is there another number in our problem that has that 35-cent value that could fit those two together to add up to be equal to 1? Well, it's right here. So the first two things that I'm going to add when I would add this up would be 65. The reason why I do that first is because when I add these up, I'm going to get to carry that value over and then make my addition simpler. 5 plus 5 is 0, carry the 1. 3 plus 6 is 9, plus 1 is 0, 10, carry the 1. And now here's where I have that whole number value. 1 plus 3 is 4, plus 2 is 6. Adding those two together gives me this nice, even whole number. Now I can go and I can add 145 to that, and because my addition has been simplified in that way, it becomes a lot smoother. The total of all those is 745. Now if you add these together by themselves, or all three of those in order, you get the same exact answer. But the skill here is to create what you're going to be adding together first. I'm going to use the associative property to say I'm going to add these two items first, because 35 and 65 made that full dollar amount. It made that nice and smooth and easy to solve in that way with that skill of number sense, putting things together that fit together just like that. Hope that helps you with your assignment. Good luck.